Okay, so today we move to the second section and look at transactions. We have so far looked at triggers. We defined what triggers are. We described the characteristics of triggers. And we also looked at how to create and manage triggers. So today I want to look at the second part of this chapter, which is implementing transactions. As you can see, the outline is the second part is creating transactions. I'll start by explaining what they are, and then we'll look at creating transactions, then reverting transactions. I think that should cover for, I doubt we'll go to the third subsection. Transactions are used when you need to execute a sequence of T-SQL statements as a single logical unit. That's the important point. A transaction will be treated as a logical unit. In other words, it's like it's the smallest unit which you can break down your SQL statements. Okay. The reason why transactions are implemented that they are used to ensure data integrity. In a multi-user environment, that is in an environment where the database management system allows multiple users to access the server or the database, you are going to have instances where multiple users will try to access the same database resource at the same time or concurrently. Okay. And this can lead to errors unless it's handled properly. Think of a case where this user is I just started updating information in the table. He has modified the employee ID, and just then another before that is complete, another user will try to search and look up the employees. So you have the employee who is going to first see maybe the old employee ID, but before they finish their sequence of statements, that has been changed to a different value. Okay. And so this can result in loss of integrity of data. SQL Server provides a number of means to ensure that that is prevented. One such mechanism is the use of logs. Logs provide a mechanism to secure resources until one transaction has been executed successfully. So when a certain transaction is being executed, the SQL Server is going to lock access to those records until the first set of transactions have been completed. So the mechanism used to do that is what is referred to as locks. And we're going to look at those in this chapter. Now, we're saying a transaction is a sequence of operations performed together as a single logical unit of work. They don't have to be dependent on each other, okay? But in your view, as the person who is designing the database or who is modifying database objects or using the database, may want certain operations to be performed together. Like I said in the previous lesson, there are certain cases where the updating of or changes to information in one table may require that changes be made in other related tables. And I gave you the example of a banking system. When the money is being transferred from one user account to another, you might have a situation where money has been deducted from one account, but before or during the process of updating or crediting the recipient or the payee, something goes wrong, and that is not completed successfully. So you can have a situation where money has been deducted from an account, but it has not been credited to the account to which it's supposed to go. Now, so when you have such cases, you have to implement these steps as a transaction. You may have found yourself, if you use ATM machines, you are at the ATM, you enter your PIN that goes through, you indicate that you want to withdraw some money, you indicate the amount. But when the money is being ejected, the machine develops a fault and the money doesn't come out. Again, it will be wrong to let the system indicate that you have withdrawn that money from your account because you haven't received the money, okay? So that is supposed to be done as a transaction so that all the processes involved must be completed successfully. Otherwise, the database should reverse everything to the way it was before. That's a transaction. And transactions have properties which are referred to as acid properties. That is an acronym. It stands for atomicity, consistency, isolation, and durability. Atomicity means that the data modifications are performed, or all of them are performed, or none of them are performed. That is, the changes must be all made, or all of them shouldn't. What I mean is, it means that the term is taken from an atom, like the smallest unit of matter. Okay, so it implies that the transaction should not be split, whereby some processes have been performed, others have not been performed. All of them have to be performed, or none of the processes should be performed. Consistency states that all data should be in a consistent state after transaction is completed successfully. Sorry, I left out something there. Okay. So what that means is that once the transaction has been completed, all the data that has been modified should be in a consistent form, should adhere to the rules which may have been defined for that table. Okay. Isolation states that any data modification made by concurrent transactions must be isolated from modifications made by other concurrent transactions. What that means is that if a user is updating, if there are two users using the database and they are both trying to update records on a specific table, the process of updating that information in that table should be such that whatever each of the two users is doing should not interfere with what the other is doing. Okay. So when you start the process of modifying or updating data, a record or a certain number of records, the SQL Server is going to isolate the fields which are affected, so that if there are others who are trying to do the same, they should not be able to do that. Okay. And the last, the D stands for durability. This states that any changes or any change in the data by a completed transaction remains permanently in effect in the system. What we are saying is this. This database try to avoid cases where you are updating a record. Now, before you complete that update process, another person starts updating. So immediately you update part of maybe a field in a record. As you update, as the system is updating other records, you know, it's although it's in microseconds, but when you have a lot of people, it's possible. As the system is updating other columns for the same record, another person can update and overwrite what update you have made. Okay, so that when you try to view what you have just done, you get something else. Okay, so durability means that the changes that have been made to data should be permanent, not permanent, should remain in the system until an appropriate time when the next person makes the modification. Okay. So those are the properties of a transaction: ACID, atomicity, consistency, isolation, and durability. As I said in the introductory remarks, SQL Server provides some means for some mechanisms for maintaining data integrity. Transaction management ensures that atomicity and consistency of all transactions. A transaction must be successfully completed after it starts, or SQL Server will undo all the data modifications made. The second mechanism is the locking mechanism. This one preserves transaction durability and isolation. So what it means is that when a user is running a set of operations affecting certain columns for a particular record, those records should not be modified by other users of the system. They are going to be locked. Okay. When you're looking at transactions, there are different types of transactions. There are auto-commit transaction, implicit transaction, and explicit transaction. Auto-commit transaction is the default transaction management mode. In other words, when the database has not been changed, when you have not done anything else, that's what is going to be implemented. Okay. This is based on the completeness of every T-SQL statement. Transactions are automatically committed or rolled back. A statement is committed if it is completed successfully, and it is rolled back if it encounters an error. So what we are saying is, when you begin the process of maybe updating certain rows, SQL Server is going to ensure that if you complete that information is going to be saved into the underlying table. If for some reason something goes wrong, it's supposed to reverse whatever changes have been made. Now, implicit transaction is one where you do not need to define the start of the transaction or the end of the transaction. You are only required to commit or roll back the transaction. In other words, when you perform implicit transactions, SQL Server is going to understand that what you are doing should be treated as a unit. And all you need to do is to commit at the point that you have deemed necessary or suitable to commit those changes that have been made. Or you can put a statement logical statement using if else to reverse what has been made. You need to turn on implicit transaction mode to specify the implicit transaction, and I'll be showing you in a moment. Now, SQL Server starts the transaction whenever you execute any of the following statements that are listed there. So when you execute an alter table statement, insert table, open, revoke, truncate table, select statement, grant, create, drop, fetch, update. All these statements, when they are being executed, all the changes associated with that statement have to be treated as a unit. Okay. We haven't looked at some of these, but we'll allude to them, I think, in the last chapter. But most of them should be familiar. Revoke is a DDL statement that is used to change user permissions or rights. Grant is a statement that is used to give a user rights to a certain database object. Once you turn on implicit transaction, transactions remain in effect until you issue a commit or rollback statement. In other words, when you enable implicit transaction, after that, you start issuing statements. Those statements are all going to be considered to be part of one transaction, and no other user will be allowed to perform any operation on the affected roles until you commit them. That is to save the changes that have been made, or roll back to reverse the changes which have been made. After the first transaction is committed or rolled back, SQL Server starts a new transaction. So it will be a continuous process. You commit, then it will assume that the next statement you are going to enter is part of a new transaction. And it will lock until you commit those changes. So you can use it in cases where you are performing some tasks, some illustrations on data, and at some point you want to reverse those changes. You can turn on the implicit transaction mode by using the set implicit transaction on. That's a statement that is used to set to turn on implicit transaction. Once you do that, every statement that you enter is going to be treated as part of a transaction up to the point where you commit the changes or you reverse the changes. And when you no longer need to use implicit transaction, you have to use this statement to turn it off. Okay. That is going to turn off the implicit transaction mode. The second transaction mode okay, here I have an example of implicit transaction. You use that statement to turn on implicit transaction, and then you use insert data into a table called depositor, and in there you're going to enter 1, 2, 3, 4 rows. Those are part of one and the same transaction. When you come to this point, you commit those changes. That means that now you are ready to start a second transaction. So after this statement, what follows is part of the second transaction. In this one, you are using select count to count the number of rows in this depositors table. And if in the first part, this table was empty, then you are going to have you are going to have 1, 2, 3, 4. This part is going to count and return 4. I hope that is familiar, this part. We say that when you are using the count function, if you want to just count all rows in a table, you put the asterisk between the brackets. That means that you're going to count all rows in that table. Once it has counted, it's going to execute this one, or as part of the second transaction, where it's going to insert a new record for a fifth depositor. Again, it's going to select all the depositors in the table. So these 3 statements are part of the second transaction. When you come to this point, you commit changes. You commit the transaction. Then you are saying all these have now been completed successfully, and other database users can now access those affected rows. Before you do that, any attempt to access this table, these rows in this table, is going to give an error message. Let's do a demo for this part. So before I do the transaction, I'll need to create the table. And let me just create table in this the table I'm creating is the depositor table. So I'll say create table name, open bracket, it has 2 columns. What data type should be assigned to customer name? Okay, so voucher. And we don't know, some people might have very long names, so that's a bit like that. And we set that maybe as a primary key. Of course, we are assuming that not now. Okay. The account number, you can use numeric and up to 4 or 5 digits. Okay, so 5 digits. Just 7, no decimal places. So I'm creating this table. So now I'm going to start this transaction. I've set this one as primary key. Okay, no, it's not a good thing. So when I start this transaction, I'm going to first insert this. Okay, so I will start by executing this. Then I can now execute that 4 rows. Now, if I went to another, so that I appear like another user, and let's try to maybe do something about it. Select phone deposit time. You've seen what has happened. My statement is still executing. Check at the bottom, still showing that it's because that table is locked. I started the implicit transaction and I haven't yet committed the results. So the user will, no other user will be able to modify the contents of that table. So I'll go back and commit. So now I get the results from. Now, because I've enabled implicit transaction, it means that when I execute that one, I am again starting another transaction. Okay. Okay. Anything unusual about this? Okay. Okay. So I have that part. So I've inserted the fifth record. Again, this other side, I cannot have access to the table because I haven't committed or rolled back the changes. Okay. So I can go back. Now I can see the results also from this other side. So that's implicit transaction. The other one is explicit transaction. Yes. Yes.
Like when you enter the index for breakdown, yeah, it agrees. While you not commit, that so does this mean that does this mean that the implicit transaction only works with modification of the table? Just like when you're modifying a table, like you did in setting, it failed to show the data this other side where you yeah, when select this other side, it is not really able to be executed until commit was executed this other side. But when count,
yes,
it agreed without the what committing. So this means it only active when someone trying to modify it.
okay. I'm going back to my PowerPoint presentation. Here we indicated that we have select statement as one of those which are used. The results that it was showing were actually for the previous, what was committed before I could, for the first part. So if I had inserted the fifth row and try to use select in the other window, it was still going to show me 4, because that would have been what would have been obtained in the previous transaction. Okay. We'll look at the types of locking mechanisms, then you'll see what results you get, why when it will show you information from the previous transaction, or when it's going to not show you anything when I come to look at locking mechanism. Okay, so just bear with me for now. Okay, so that was implicit transaction. Explicit transaction, as the name suggests, is transaction where both the start and the end of the transaction are defined explicitly. The user, or you, the database user, will indicate which one should be the start and which one should be the end of that transaction. For implicit transaction, it will just take everything from the previous commit transaction or rollback transaction. Everything will be treated as part of one transaction. But explicit transaction, you specify where you want the transaction to begin and where you want the transaction to end. These are specified using the following statements. The first one is begin transaction. Begin transaction is the statement that is going to indicate where the transaction begins. It's not going to assume that anything is part of that transaction until it comes to this point. Okay. And then the end can be indicated by 2 statements, either this one, commit transaction, where you now save those changes permanently to the table, if it's data in a table, or rollback, where you undo the transaction, you reverse the operations which have been performed. So one of these 2 is going to indicate that you have reached the end of the transaction. Anything in between begin transaction and these 2, either one of these 2, will be treated as part of that logical unit of work. But you can also have save transaction. save transaction is used to establish save points that allow partial rollback of a transaction. There are times when you are going to have a transaction consisting of a lot of statements, and some of them are some parts will not depend on other parts. So in such cases, you can create some points which you are going to save so that you can roll back maybe to that point only, not reversing everything. Okay, so you use save transaction. Okay. Begin transaction, like I've said, marks the beginning of a transaction, and the syntax is here. By the way, I need to point out this. You can either use the full word transaction, or you can use the short form tran. Both are acceptable. And that should be followed by the name, either the name of the transaction or a variable containing the name of the transaction. Transaction name is the name assigned to the transaction, and this is at the beginning. The trans name variable is the name of a user-defined variable that contains a valid transaction name. Transaction names, just like other identifiers, can contain up to 32 characters. In SQL Server, these can have spaces, but it's not advisable. If they have spaces, you must always, for example, if it's like that, then you have to always remember to enclose them inside square brackets. Otherwise, you get error messages. Committing a transaction or commit work statement marks the end of an explicit transaction. So both are acceptable. This one, okay. And the syntax is here. Almost identical to the begin transaction. Transaction name is the name assigned by a previous begin transaction statement. It can be used to indicate the nested begin transaction statement that is associated with the commit transaction statement. What I mean is transactions can be nested. That is, you have one main transaction, and within that transaction, you can define other transactions. Now, if you need to roll back, you may want to roll back the inner transaction. So when you want to commit, want to save, you want to save what has been the changes performed in one of the inner transactions, you can put the name there. It's not going to save everything that has been done so far in that transaction. It's only going to save from the beginning where that transaction name or nested transaction was defined. That is what is going to be committed. Again, you can use a variable name containing the transaction name. Any question? What's the difference between transactions and stored procedures? What's the difference? Any suggestion? A stored procedure is going to be saved as an object in your database with a name that can be referenced. But a transaction is a set of statements which you are using during a given session. They are not going to be saved as objects. Although the effects can be permanent, but they themselves, the transactions, once you close the query window, they will be removed. Is that making sense? Okay. An example of an explicit transaction. Let me explain, then we'll go to the, we execute this one. So you start by giving it a name. You say begin trans, and that's the name I've assigned to it. And in that transaction, first I'm updating employee details, where in this table, I'm setting the salary to 10,000 for an employee called Robert. Next, I want to update employee details, the same table, and set the salary to 12,000 for an employee called Jack. So when I need to perform these two actions as a transaction, or I need to make sure that when I update this one, I should also update this one, then I need to execute them as a transaction. And so you have to indicate the beginning and the end. Now, if it happens that, what will happen if there's no employee with the name Jackie? Instead, maybe there's Jacqueline. what happens? The transaction would have failed. Come again? The transaction will notify us of an error that it could not be performed and indicate that there's missing record. Okay. But if it was just executing this as statements or as a batch, this one, if it's there's Robert, this one will be successful. But this one, if there's no Jackie, will fail. But because we are treating it as a transaction, they have to be reversed. A question. Which of the following properties does a transaction not possess? Hmm? What? Atomistic. What do others think? Yes, miss. Separation. Instead of separation, what is that? Okay. But what's define the characteristic of separation? Yes.
A separation whereby it begins the transaction and the community, the entire transaction. So that transaction has to be separate from the other transaction.
It's not called separation. It's called isolation. Yeah. Okay. So the answer is separation. Remember, the acronym is ACID. Atomicity, consistency, isolation, and duration. Any questions? Any questions? Yeah. Because what we are saying is all the processes are being treated as a unit. If there is an error encountered in one of them, then the database has to reverse that. All of them. So you shouldn't have a situation where, yes, one statement can execute successfully, but because it's part of the transaction, the whole transaction has failed. Let me look and see if I can get. Okay, I'll illustrate that when we get to vetting transactions. Okay. So we have looked at different types of transactions. We're saying the first one is auto commit transaction, and that's the default transaction mode. Meaning, when those statements are being executed, by nature, the SQL Server. Okay, let me illustrate this. Okay. Let's have this table. Okay, I want to use the table called select. Okay, so let's take department number 1. So it's update. Update. Table is human sources department. Set modified date because equals. Say where. So no, I want to do this. I want to create something that will give us some error. Okay, so you say I want when the group name or just name, we want it to be engineering. Where department ID equals 1. So if I execute this statement, what is going to happen is that the engineering, this one for the name, is going to be okay. Okay, this part is okay. But this part, because I'm trying to enter a string which cannot be converted into a column for date and time, this part is going to fail. So what is going to happen is that as I am updating, this will be changed to engineering without department. Then the next column it will attempt to change to that. And once it fails, then this one also is going to be reversed so that it will just be the way it is before executing. That is the first type of transaction, auto commit. So there are certain statements which in and of themselves require that they should be completed. Every task should be completed. Otherwise, things should be reversed. Okay. Now, the second is implicit transaction. And we said you have to enable implicit transaction by using the statement set implicit underscore transaction on. Once you do that, then the statements that follow, where there is insert, select, update, and the others, are going to be treated as part of that transaction until the point where you say commit transaction. And again, once you say commit transaction, the statements that are now going to follow after commit transaction are going to be treated as part of one transaction. Until maybe you get to a point where there is a rollback transaction. Again, what follows after that will be treated as one transaction. That is implicit transaction. You only indicate the termination of the transaction. The third type is explicit transaction, where you specify where the beginning of the transaction and the end of the transaction. For an explicit transaction, you can even give it a name. Implicit transactions will not have name. It will just reverse everything up to the last commit or rollback statement. Okay, so let me look at reverting transactions. That should be. Okay, sometimes all statements of a transaction do not execute successfully due to some problems. The rollback transaction statement rolls back an explicit or implicit transaction to the beginning of that transaction or to a save point within the transaction. Save point allows you to discard part of a long transaction instead of rolling back the entire transaction. So we're saying that rollback transaction is used to undo the changes which have been made, either from the beginning of the implicit transaction or explicit transaction, or from the save point. So if you have an explicit transaction and somewhere halfway through, you have declared, you have saved the point. When you reverse, the rollback is going to reverse to that point according to what you have indicated there. That's the syntax. So it will roll back to either the transaction name or a variable containing a transaction name or a save point variable. Okay. Here is an illustration. This transaction is used to update contact information for people in the AdventureWorks database. We are giving the transaction that name, TR1, and the transaction begins from there. Why are we using this? Begin try. What's the purpose of using try in this context? Remember, in the last chapter, we did look at how to handle errors when they occur. And one of the approaches was to use try and catch. Okay. This try and catch is where the statements that you want to execute, you put them from where it says try up to some point. And that is going to be indicated by end try. Now, in the event that something goes wrong in any of these statements, you define what should be done or what should happen as a result. And that is what you put under begin catch. Okay. So what is going to happen is SQL Server is going to execute the statements from there all the way up to there. If everything goes well, then that's it. And proceed to what comes below there. But if something goes wrong in one of these statements, maybe this ID, or maybe this ID doesn't exist, or this ID is too big for the column, then what is going to happen is everything else is going to be, after that, is going to be skipped up to where it says end try. Then it's going to look for where it says begin catch and execute the statements which are included in try catch. That way, you are able to roll back, reverse the changes that have been made. Now, I need to clarify this. Implicit transactions and explicit transactions are not going to automatically reverse the changes. Auto commit transaction will automatically reverse the changes that have been made if something goes wrong. But implicit transaction, explicit transaction, you have to include a rollback statement to reverse changes if something goes wrong. Okay, and this is one way you do it. You use try and catch. Okay. So let me just copy this. Okay, first I want to see. Now let's look at the code before we execute it. This transaction not there. We are giving it this name, and what we are going to do is first we are going to update the table code contact in schema code person, and we are going to update set the email address to that. Okay, that's the first statement. Next, we are going to go to another table called employee address. And in employee address, we are going to set the address ID to that number for an employee where employee ID is 1. And once we do that, if all these statements are executed successfully, then we commit, we save the changes. In other words, once we stop this transaction, those changes are still going to be reflected in the table. The second statement is this part. We are using select statement to display a message to confirm that the two updates were executed successfully. The update of this email in contact and the update of the address ID in employee address. But if something has gone wrong, maybe, like I said, this number is too big or is set to be, this column is supposed to have unique values, and already there is another employee ID of this, which is exactly like this, then this part is going to fail. And when that happens, the control is going to be passed to here. And it's going to reverse this, the changes, drawback transaction, right from there. Okay. Okay. It's not going to commit. Okay. Now, I need to look at the table. Contact. Okay, it's a long one. So this is the field that we want to update. And once we update that, we also want to go to another table. This one. So here we are going to look for employee ID. This is for which employee? Number 1, right? Employee ID 1. We're going to, oh, sorry, it's the employee address. Employee address. Employee address ID should be set for number 1. Should be set to that number. Okay. Okay. So what type of transaction is this one? This one, which we're about to explain. What type of transaction? Come again? what does that say? It's an explicit transaction because we have marked the beginning and we have marked the end. Okay. Okay. So we are getting a message. Conversion failed when converting data and or time from string character. Okay. One row is affected, 0 affected, completion with errors. Now let me see what. Okay, so I'll go back to this. And see what changes we have made. Address, that's the email address, contact, that's on contact. For contact ID, 1070. So let me just get that. So you've seen the email address hasn't changed. So can check the other table. This one, where employee ID is one. Employee ID is that. Address ID is still 61, not the one that we wanted to change. Wanted to set the address ID to that. So something went wrong, and because of that, changes to both tables. Although we got a message confirming that some rows were affected, but because of something that went wrong, everything has been reversed to the way it was. So that is reverting transactions. You have to deliberately roll back the changes if you are using explicit or implicit transaction. Any questions? Any questions? I need to come and look at the types of locks and answer the question that Gift asked. Come again? When you want SQL Server to roll back the yes. Okay, let me see what you